Hello everyone, welcome back to my channel. I'm Renisha. My matrix number is 01DEE24F1154. Today I will be presenting on the topic Environmental Control Strategy for Steam Power Plant. In this presentation, I will focus on several key points that plays an essential role in minimizing environmental pollution. They are a suitable environmental control strategy method which responsible for pollution, including block diagram, comparison between two filtering method, and finally how this method contribute to an affordable and clean energy. Let's step into our next slide. There are a lot of methods to form a healthy environment, but I'm going to explain about electrostatic precipitator, commonly known as ESP. ESP is an advanced device used to remove fine particles such as dust and ash from flue gas during power generation before it's released into atmosphere. It works by applying electrical charge to the particles present in the gas streams. These charged particles are attracted to metal plates where they are collected and eventually removed. The ESP is highly efficient. It can achieving up to 99% removal of even the smallest dust particles. Although the initial installation cost is relatively high, but the operational and maintenance costs are comparatively low, making it is a cost effective solution over time. In addition, ESP systems generate minimal waste that contributing to a cleaner and more suitable power plant operation. Here is the block diagram of ESP. Got two flow. First flow start with flue gas from boiler, travel towards dust collector by ESP. Those collected dust form into dry ash and finally reach silo. The second flow also start with flue gas from boiler, travel towards dust collector by ESP and then go to FGD after FGD become clean flue gas and finally ready to release into atmosphere through stack. Before move to our next slide, have a short intro about flue gas desulfurization. The short form is FGD. FGD is a system that removes sulfur dioxide emission from large electric utility boilers. Sulfur dioxide is a major cause of acid rains, so by removing it, the environment stays protected and improving air quality. Both ESP and fabric filter are used to remove dust and fine particles from the flue gas of steam power plants. However, they differ from aspect of efficiency, operational cost, complexity, and last but not least, environmental impact. Let's look at this aspect one by one. First, effectiveness. ESP very effective in removing fine particles with up to 99% removal even for microscopic dust. But fabric filter, known as baghouse, also highly efficient and in some cases can remove nearly all particles larger than 1 micron. Here, both are effective, but ESP performs better in high temperature and high volume gas flow conditions. Next, cost and maintenance of ESP has a higher initial cost because it requires electrical equipment and strong construction materials. However, maintenance costs are low as it doesn't require frequent part replacement compared to fabric filter. It's because regular need of filter bag replacement which increases maintenance cost even though as a lower installation cost. In this case, ESP is more cost effective in the long term, while the fabric filter is cheaper at the beginning but costly to maintain. After that, complexity of operation. Even though ESP more complex in design that involving electrical system for charging and collecting particles, once installed it is easy to operate automatically. But fabric filter simple design which only using filter bags still require manual checking and replacement of the bags periodically. So, no doubt, ESP is technically complex but operationally simple, while fabric filter is mechanically simple but requires more manual work. Lastly, ESP has a healthy environmental impact by producing very less waste. Those collected particles also can be reused in construction or disposed of safely. For instance, the collected dust or ash from the ESP can be mixed with cement and bricks for building purpose. This is not only reduces waste disposal but also promotes sustainable material reuse. Solid waste collected from filter bags may require special disposal. The conclusion of this aspect, ESP is more environmentally friendly compared to fabric filters. Both ESP and FGD play a significant role in ensuring cleaner air by removing dust, ash, and harmful gases from flue emissions. By controlling these emissions, both systems improve air quality and protect the environment from pollution. Although the initial installation cost of these systems can be high, but they require minimal maintenance and operate efficiently for long period. This leads to reduced operational costs and saves money for the power plant over time. Through emission control and efficiency improvement, these technologies make energy production more sustainable. Not only that, they allow steam power plants to operate longer without violating environmental regulations, ensuring a steady and cleaner energy supply. This supports the greener energy system and helps countries achieve long-term sustainability goals. Cleaner air means healthier communities. These technologies help protect public health by reducing the spread of hair-related diseases such as asthma and lung infections. In conclusion, environmental control systems such as the ESP and FGD are essential components in modern steam power plants. They not only reduce pollution and safeguard human health but also play an important role in ensuring sustainable and efficient energy production. That's all for me. Thank you for attention. I hope you all learned something new today. Thanks for watching.